So this is number one. This is the one about the two parents who built a toy. The idea with the toy is that the kid would shoot a ping pong ball from this launching position, and their goal is to get it within this band that is 5 centimeters wide, and that target line's right in the middle. So it's important to note that this is in the middle, so it's 2.5 centimeters either side from the middle, and then they win a prize if they get it in that shaded band. So they have constructed the two catapults to slightly different plans, and they tested them, and these two dot plots show the distances that each ping pong ball went in their test. So they did 40 ping pong balls from each catapult, and then we ended up with these distances. So we're going to look at part A, comment on any similarities and differences that we see in the two distributions. So I first want to talk about, and I put this as a hint, that we want to make sure when we are comparing or describing numerical graphs, we should be talking about the center, shape, and spread. So CUS and BS, center, unusual features, shape, and spread. Unusual features is not always a must. It kind of just depends on the situation if they specifically ask you about it. Typically, an AP exam for response question isn't going to count off if you don't mention outliers, especially if it's not super clear that something is for sure an outlier. So the other thing I want to be careful of is that I am comparing them. So I should be talking about similarities. So when I talk about center, are their centers the same, or is one noticeably higher than the other? For spread, are they roughly the same, or is one noticeably wider than the other? Do they have a similar shape, or are the shapes different? So I'm going to talk about all of those with these, and I'll kind of flip back and forth between the graphs and my little text here. So I'm going to start with center. So center would be kind of where the peak of the graph is. So I noticed that the center for catapult A is a little bit unsure. We kind of maybe have potentially two centers, but they are fairly close to each other. So I'm going to go ahead and call this one overall unimodal. Remember with a dot plot that we're literally seeing every possible number. If this were converted to a histogram, it's very likely that those two quote-unquote centers would be kind of smushed together into one or two bars that are right next to each other. So I'm going to go ahead and call this roughly unimodal. If you called it maybe a tad bimodal, I think that that wouldn't be counted wrong. But I'm going to say catapult A is roughly unimodal and fairly symmetric, maybe a tiny bit skewed to the right. And catapult B is also unimodal with a center a little bit higher in that kind of 137-ish range compared to the center for catapult A, which is closer to like maybe 135-ish if we kind of average those two centers. So catapult B has a slightly higher center and is unimodal and also roughly symmetric. So I'm going to talk about those, and then I'll come back and talk about spread. So that is my discussion of the shape as well as the center. The other thing I wanted to point out, we should always be talking about things in context, so include units where appropriate, but also make sure you're using the word distance somewhere in there. As I was typing that, I went back and put that in. So that is important, kind of talking about the words that you're dealing with in this specific problem. So going back to spread is the other thing I want to mention. So the biggest difference here, I think, is with spread. So catapult A has a very, very wide spread ranging from like, what is that, about 120-ish, a little bit above 120 all the way up to 155 compared to catapult B, which is in like 133-ish range up to maybe 144. So it's much, much more spread out with catapult A's distances than catapult B's. So catapult B is much more consistent. This may also be where I would want to mention if I see any potential outliers. Again, on this problem, they weren't necessarily looking for you to do that in the AP grading, but we could maybe say that the catapult A has a couple outer lying ping pong distances that could be considered outliers. Catapult B doesn't have any apparent outliers. And that's it. So that is our description of the similarities and differences. So again, important things, center, shape, spread, and then also make sure you are actually comparing. So talking about which center is higher or lower, which spread was wider or narrower, are the shapes the same or are they different? On this specific problem, if you perfectly described every piece of both, but you never compared them, like never said what was the same and what was different, you would have gotten an I or incorrect on this part of this problem. So make sure you are comparing when it asks you to compare. So moving on to part B. So part B asks if the two parents want to maximize the probability of having ping pong balls land within the band. Which one of the two catapults, A or B, would be better to use? So the answer to that question, based on our graphs, is catapult B, because catapult B has a much lower or narrower spread, which means overall it's much more consistent. So the kids are going to get within that 5 centimeter band a lot more often. So we have more data kind of squished together compared to catapult A, which had ping pong ball distances that were much more spread out. All right, so that is part B. And then last but not least, part C is asking, using the catapult you chose in part B, explain how many centimeters from the target line should the catapult be placed. So again, we're trying to kind of fit most balls getting within that 5 centimeter range. So the answer to this, and the AP would have taken a couple different things on this. It would have taken if you actually found the median or even the mean. So if you looked at literally where every dot was and figured out where's the middle one and put your target line there, they would have taken that as long as you explain that's the median. Since this is roughly symmetric, the median is a good representation of center, and that should get a high proportion of balls within the 5 centimeter range. You also may have figured out exactly where I should place this to where the most of these dots rest within 5 centimeters either way. And that might have put it in kind of a slightly different range. So I'll show you on AP Classroom's scoring guidelines. They said they were looking for you to say it's placed at the median. It explains why the median is appropriate. And again, that's just because it would represent the center well, since the graph is roughly symmetric. Or you may have said somewhere in the range of 137.5 to 139.5 and explaining that this has a highest proportion of balls within the target band. So either of those answers would be appropriate. I'm going to type what I would have typed here. So that's kind of what I put. Again, it's about the center, and that it would include approximately 75% of the ping pong balls within the 5 centimeter band. Again, you could have said a couple different things as long as you justified it well enough and fully enough. The goal with this question in particular was making sure you know how to describe numerical data and compare numerical data, and really just pulling out the important pieces. So B was referring to variability. Do you understand what variability is and how to apply that to a problem? C was focusing in on center. Do you understand what center is and how to apply that to a problem? So that is number 1. Number 2 is the one with the scatter plot. This is our linear regression example. So it says the Great Plains Railroad is interested in studying how fuel consumption is related to number of rail cars. So we have this table for a sample of 10 trains on the route, and then we are also given a scatter plot, a residual plot, and we are given our linear regression data from the output. So we're going to go straight to part A. Part A says, is a linear model appropriate for modeling these data? Clearly explain your reasoning. So for that, we're going to look at our graphs. So the big thing without determining whether a linear model is appropriate, we should not be looking at the output. If you try to use like your R squared as a justification or your slope as a justification, you would not get any credit for this. We have to look at graphs. For scatter plot, we can see that it is fairly linear. There doesn't seem to be any curve or any other relationship that might explain this data. And for residual plot, you're actually looking for no clear pattern. Specifically, you don't want to see curved pattern that might indicate a slight curve in the data. So with this one, we don't see any clear pattern, which tells us that the dots are kind of scattered nicely above and below the line of best fit. So I'm going to say something like that. So that is it. And I will point out for this one, it's not going to be for every linear regression problem, but for this one, when we look at AP Classroom's scoring guideline, they actually just said if you said a linear pattern is in the scatter plot, or if you said there's no pattern in the residual plot, either of those would be appropriate for you for your explanation. You would get full credit for either of those. So in this one, they didn't actually insist that you say both like I made you do in class when we learned this unit. Never hurts to say both, and we never know exactly what AP graders are going to be looking for, but in this particular case, you could have referred to either graph and gotten full credit, as long as you talked about a graph and explained it well. So that is part A. So part B is saying that the fuel consumption cost is $25 per unit. Give a point estimate or single value for the change in the average cost of fuel per mile for each additional rail car. So for that, we really have to look at our data down here and know what slope represents in this problem. So slope in this problem would represent the average or typical increase in fuel consumption for every increase of one rail car. So when we talk about slope, we say for each increase of 1 unit in X, the model predicts an increase or decrease of slope units in y. So for this one, if I were describing or interpreting the slope, I would say for each increase of one rail car, the model predicts an increase of 2.1495 in fuel consumption, whatever that unit is. So this is saying, part B is saying that the fuel consumption cost is $25 per unit. So to figure out that average change in cost of per mile for each additional rail car, all I have to do is some simple multiplication and then explain why I did that. So there we have it. So since 2.15 units represents the predicted change or increase in fuel consumption for each one additional rail car on the train, 2.15 times $25 equals $53.75 represents the predicted change in cost for fuel consumption for each one additional rail car on the train. And we might actually put change parentheses increase again, just to be really specific. So that would be your answer to that problem. So simple multiplication is all you needed to do, and just a little bit of explanation. Part C is asking us to interpret the value of r squared in the context of the problem. So the r squared value that we were given was 96.7%. If you go back to your little kind of cheat sheet for r squared represents the percent of the variation in your y variable that can be explained by this linear model for x versus y. So 96.7% of the variation in fuel consumption can be explained by this linear model for number of rail cars versus fuel consumption. And that is part C. So then last but not least, part D is asking, would it be reasonable to use the fitted regression equation to predict the fuel consumption for a train on this route if the train had 65 rail cars? For this, I'm going to go up to my graph and even my table. So this is kind of asking us to make a prediction for 65 rail cars. And what I notice from my graph, or even if I look at numbers on that column, I notice that the highest I have here is at about 50 rail cars. So this regression equation is going to work fairly well for predicting what's happening between 20 and 50 rail cars, but we don't really know what happens to fuel consumption beyond those values. So no, it would not be appropriate to or reasonable to make that prediction because we don't know what's going to happen to this relationship beyond 50 rail cars. We call that extrapolation. And that is our explanation. I will note, I don't think that using the word extrapolation is necessary to get full credit here, but if you just say no because it's extrapolation and you don't go anything further, you may not get full credit. All right, so that is number 2. So on number 3, we have a histogram. It says the sizes in square feet of the 20 rooms are summarized in the following histogram. Part A, we're asked to just write a few sentences to describe the distribution. So we're just describing one, but this goes back to, we're going to do cuss and BS to answer this question. So for this one, in terms of center, I would say we have potentially a little bit of a bimodal. We have a lot in the 150 to 200 square feet range, and then a lot in the 250 to 300 square feet range. Those might be a little too close together to call it bimodal. You might call it kind of one general center or averaged around 200 or 250, but you could potentially list that as two separate centers. So that is a center. Again, I did kind of mention that if we called it one center, maybe in that 200 to 250 square feet range, we kind of average it. But I also mentioned that it could possibly be considered bimodal. This is a good way to kind of cover your bases. If you're not sure whether you want to call it bimodal or not, you can kind of say, it's this, but maybe it's this. And that's a good way to cover yourself. So that is the center. I also went back and made sure to include context, so the distribution for room sizes, and then I made sure to include units, as always. So that's center. I'm going to move on to shape. I think typically it's pretty symmetric, and again, it could be considered unimodal or bimodal, but it's definitely very symmetric. I already talked about the unimodal / bimodalness, so I'm going to just talk about that it's roughly symmetric. So now I'm going to go on and talk about spread. So the room sizes range from about 100 to about 350 square feet, and that's as far as I'm going to take it. And then the last thing, I kind of skipped over it, was the U in cuss, but would be unusual features. There are no outliers. We may mention that the drop in number of rooms in the 200 and 250 square feet range might be considered an unusual feature. It's not a complete gap, but we definitely see a pretty major drop, and I would mention that as an unusual feature. So I said that, but then I also went back up to the top and adjusted things and kind of said that 200 and 250 is probably the approximate mean. But again, it could be considered bimodal with two peaks or modes in the graph. So I kind of clarified what version of center. I may not have to say all of that. This is a problem that I don't have good scoring guidelines for, so I'm kind of making it up as I go or kind of saying all of what I'm trying to say. So that is part A. So then part B gives us some summary statistics for the sizes. So we have the mean, the standard deviation, the minimum, Q1, medium, Q3 max, which that would be our 5-number summary. It asks us to determine whether there are potential outliers in the data, and then to sketch a box plot of the room size. So I'm going to start with calculating outliers and then go from there. So our outlier rule is we're going to deal with 1.5 IQRs away from either side of the quartiles. I'm going to find my IQR first. It's just Q3 minus Q1, so 292 minus 174. So then my outlier rule is if I start at Q1, which is the lower end of the box plot, and subtract 1.5 times my IQR, that gives me my lower boundary or fence. So basically any values that are below 27 would be considered outliers on the lower end. My upper end rule, we start at the upper end of the box, so Q3 plus 1.5 IQRs. So any values that are above 439 would be considered outliers. So we call those our fences. Anything outside of that range from 27 to 439 would be considered outliers. So if I look at my data, my lowest value is 134, which is not below 27. My highest value is 315, which is not above 439. So we definitely do not have any outliers. So now I can go ahead and make my box plot. So this is where I'm going to draw a number line. Again, my lowest value is at 134 and my highest is at 315. So I will make my number line go from 100 to 300, leaving myself a tiny bit of room above for that 315. And then I'm just going to slowly kind of start to divide this up. One thing that I notice a lot of on some tests and quizzes is there are a lot of you that are being really lazy about drawing things like box plots or even other types of graphs. You want to make sure that you have a good number line and that it's to scale. So for example, a lot of people not really even think about how far apart things are. So maybe a distance of 50 visually looked the same as a distance of 200, and that's not okay. So that's what the number line is for, is to make sure that when we draw this, that it's actually visually to scale, so that if there's a skew or if there's whatever, we can actually visually see that. Whereas if you're just kind of drawing it quickly and not even really thinking about those distances, it's not going to look like it should, and then it's not even a good representation. I'm going to go back and mark off my 5-number summaries. Notice I'm not being really perfect about it, but I at least want to make sure my number line is to scale and that I'm doing as best a job as I can at getting those numbers in the right place. So now I'm going to draw the box part of my box plot. I didn't quite get it through that dot. I don't feel like fixing it. And then I'm going to draw my tails, or whiskers. And that is our box plot for part B. So then lastly, part C is asking us what characteristics of the shape of the distribution of room size is apparent from the histogram, but not from the box plot. So the biggest thing you have to remember in a histogram or dot plot or stem and leaf plot or whatever versus a box plot is that a histogram or dot plot or stem and leaf plot is going to give us this information about modes. So that dip in data that we see in the 200 and 250 range, we can really clearly see that in a histogram, but my box plot does not show that at all. It does not show that there is kind of a dip in data in the 200 and 250 range. So that deal with modes or gaps or anything like that is not going to show up in a box plot, whereas it would show up in a histogram or dot plot or stem and leaf plot. And there we go. So the histogram, we can see that major drop off in rooms with that 200 and 250 square feet size. The box plot does not show this at all. So that is part C. So number 4 is our question that's really dealing with a lot with z-scores and normal model stuff. So I did throw one of these in here. This normal model stuff is something that's kind of threaded through the entire year. It doesn't fit really nicely within one topic that we're going to be dealing with during this season of AP Review. I'm kind of trying to throw it in different places where it fits. So this is kind of dealing with just that basic idea of normal distribution and how we find basic probabilities from it. So it says the distribution of finishing times for women was approximately normal with 259 mean and 32 standard deviation. For men, the mean was 242 and the standard deviation was 29. So it says the finishing time for Clay was 289 minutes. Calculate and interpret his z-score. It says standardized score. You have to know that that means z-score. So I'm going to go ahead and calculate that. And then it wants us to interpret that z-score. So a z-score basically tells us how many standard deviations above or below the mean this particular value is. All right, so that is part A. Moving on to part B. Part B says that the finishing time for Kathy was 272 minutes. What proportion of women who ran the marathon had a finishing time less than her? So we're going to do what we did for Clay, but we're going to take it one step further and use a z-table to find the proportion or probability of having a finishing time less than Kathy. So for Kathy, her z-score indicates that her finishing time was 0.41 standard deviations above the mean for women. So to figure out the proportion who ran less than her, I'm going to go to the z-table. If you don't have a z-table at home, remember that you can get it by going to the APStat website. So misscalvin.com or sites.google.com/roundrockisd.org/APStat. So if I go under more and then go to tables, that will pull up my z-tables. You can always print these. So this is my z-table. My z-score was 0.41. Remember that my z-table automatically is going to give me the proportion that is less than a particular z-score, which in this case is what we want. We want what proportion of women had a finishing time less than her. So I'm using what we have on the z-table. If it were asking for greater, I would do 1 minus. But we want less. I'm looking for 0.41. So I see that proportion is 0.6591. So I'm going to write from my z-table 0.6591. And then I'm just going to write a little bit of explanation. I think on this one you could get away with just putting the number. You might want to put like from z-table, but I'm going to kind of write that out in words. So there is part B, and then last but not least, part C is saying that the standard deviation of finishing time is greater for women than for men. What does this indicate about the finishing times of the women who ran the marathon compared to the finishing times of the men? So standard deviation is a measure of spread. Specifically, standard deviation is the average distance from the mean. So women's finishing times were about 32 minutes from the mean on average, whereas for men, the finishing times were about 29 minutes away from their mean on average. So when I explain this or interpret what this tells us, I want to mention variability, and then I also want to make a direct comparison between women and men. The scoring guidelines for this question wanted you to make sure and mention some form of variability or spread, saying that standard deviation is a measure of spread or that it relates to variability. And then again, to make that direct comparison, saying that women's finishing times are more spread out or have a greater variability. So that is part C, and that is the end of the classwork for this week. Good luck on the homework. Make sure you're emailing me if you have any questions. Bye, guys.